Good afternoon, YouTubers. Today we're going to be studying this small steam engine, the concept, and this one is particularly interesting to me. This design is using this rocket arm, and that's kind of you know make a big difference between when you have both cylinder in parallel. I mean, this guy here and this one. This is the power cylinder, and this is the sliding valve. So most this well, I would not say most design, but for a small engine like this is one of you see a lot in in YouTube. This type of design that use this kind of a rocker arm. So now, where this come from? Basically, I got an idea. Let's see, from this guy, this page here, and it's kind of interesting. This is kind of old, October 2008, but it got pretty good information about how to put this together. And as you can see, it's kind of a picture of the unit running here, and a little bit more clear here. But what it's all about here is the rocker arm, and this is a nail that is kind of work as a sliding valve. Either steam or air go in through here, and that power the piston that is in this cylinder. And he used another instead of using a flywheel, he used a piece of copper here, pipe, just to get the inertia going. And so you can see most of the details. And here's the nail, that when the nail is all the way this way, it kind of block the steam or air getting in. But when the nail start, and so the power piston coming down, so it is this space here that allows air or steam to go out. So steam or air will go out this way. But as soon as this nail come this way, so then that's when you get power into the piston. So it's pretty neat, pretty efficient the way it works. And here's a steam, the boiler for this equipment, and that's pretty much it. You can see this last one. This is very old. As I said, this was prior the elimination of Flasher. Flasher is no longer available, but there's a trick that you can go to Firefox and get sort of like a Flasher emulation, and will allow us to see anything that you want to see, even at that old. So for example, right here, let's open this big. Let's see if I can do that. Enter full screen. There we go. And here is he's hitting the steamer, and here's this like a hose here. It's like the release valve in case something get with too much pressure. And here's the steam is getting connected here, and that's pretty much how it works. So basically, I took this as the idea of how to put my unit together. And with that said, let me get out of here for a second. Let me go back here, and everything looks good. I haven't yet, well, not that I will do that, but the idea is to allow you to see the details about the sliding valve and how it operates, because you can see there's a good timing here between the sliding valve and the power piston. Let me get the browser here, and here's the name of all the elements that I'm put together. Like for example, let's eliminate for once the sliding valve cylinder, and that not to eliminate, just to hide it, so that valve cylinder, we're gonna hide that, because you can see the recess that this sliding valve has, because when it's get deep into it, it allows, you see now, as the piston push down, air will escape through that recess that you have on the sliding valve. Let's put the sliding valve back. Sliding valve right here. See, air go right through here, And so that's basically very important for the timing. Now, uh, I spent a few more, I would say, more time into this design that I was originally planned to, just because this valve, I thought to put it together, I mean, this rocker arm, put it together using this concept here as enable contact set. But the more I thought about it, I said maybe might not be a good idea, because I know Fusion 360 has this problem with contacts, and so I decided not to use contact and go, with pretty good joints connection. And as you can see, you can design definitely this by pushing the rocker arm, and the rocker arm will do its trick. But on this design, I went through, using joints all the way as shown here. When I finished this design, I had a problem. I got something misaligned a little bit, just enough. I mean, for the real system, it might work without any problem, because these are wire. I mean, these are not, and they can bend, and allows for some imperfection. But here they have to be perfectly aligned for Fusion 360 to take care of it. So as you can see, I end up having a kind of a very different connection here on the eccentric. And basically, let me get it this, and that was very interesting. And I probably think that there's a misalignment somewhere. I didn't realize that until the end. So let's escape from here and let's take a look to this guy here. Is that the guy? Let me see. Edit join for 1 second, and motion. Yeah, right here. You see, the motion is a bold type of motion between the rocker arm and the eccentric. Animate, and that provide enough freedom to get this going, and capture some of the misalignment that I had when I was doing this design. But that's just things that you have to be careful, particularly because these are stiff. They don't bend like wires might do in the when you use bicycle spoke, that they I mean, they will bend. They have some flexibility that will facilitate some of this imperfection, but not in this case. So I just changed the type of connection, and that will make life easier. So let's go back here again, and so let's do a faster speed maybe. All right, capture position. $359. Can I do 100 here? Mm-hmm. Okay. So that basically will do. Let's get this out of the way so that we can take a deep look at what's going on in the system. And so this is kind of nice. So when the piston goes down, air will go in, or steam will go in to push it up, and through the sliding valve. If I get the sliding valve out, let's see, sliding valve cylinder, there we go. So you can see now at the top of it, let's check how the sliding valve looks like. it will allow air or steam to go out quickly. So there's a hole right here on the cylinder that will allow for steam to go in and exhaust steam to go out right through this. Let's see if I can put that back. So let me explain a little bit better this timing issue so that first thing, let's look at the when I'm at top and the power piston is at the top. The only thing that he can do is going down, and to go down it needs to allow for the air or steam that is in all this area has to be able to escape, and to escape the recess within this valve need to be shown, and that's basically what will start to happen right now. As I go, I move the flywheel down. Let me see if I can get a better job here. There we go. Right now, right there, all that what I'm seeing right now is the recess. Let's go back again. That's close. Now is the recess, and that's important because that's where steam or air will come out. If I get the, you see, this is what you're seeing now, and this is what these lines are all about, to get you an idea of what's happening. So you are watching right now the recess because the power piston coming down, and steam or air need to escape right through that recess. So at that point, what is happening is all the steam coming this way is blocked by this part of the valve. So if I keep moving, keep moving, keep moving, more recess is shown until now goes right to the bottom, and to the bottom. Let's put this cylinder back again. Now you start to see a little bit of steam trying to get in through that little gap there, but a little bit more, move more. There we go. That open is now is open full, meaning that the piston, power piston, is going to go up, 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 and now the cycle will repeat itself because the power piston need to go down, and you have to have a recess, and that is going to happen now. There we go. That's the recess. You can see it right here, and the piston will all the steam here will escape right through that recess until you are at the bottom, and the bottom then it open, but it open steam or air from this side to get into the power piston and move it up. Well, that's basically the timing. Can I do animation again just so that I can fix it itself? There we go. That could happen. It's animating too many things and something gets screwed up. But animating. Oops. Let me find out. There's so much thing here, so much joint. Sometimes you get the wrong one. Anime model. There we go. That's the right one. Super. More into some of the ideas where this come from. You might get it again. Let's see. Some of them you can get it from here. I mean, this guy did very good. You can get forward. Let's see what else. And the one that I picked from this many design was the McCabe runner. So that's basically a good idea about this kind of a rocker arm pivot, for the sliding ball. And they're kind of neat. Make, from one block you can design both things, the sliding ball and the power piston. So here's some of the schematic and the timing. Here's the timing for it. So and here's the sliding valve, which is basically a nail. So when the nail is this way, then the piston can go down, the power piston can go down, and air or steam can escape. So that's basically it. Let's go back again to Fusion. And as I always said, be safe, whatever be your final destination. Have a good afternoon. Bye.